So here we go with some synthesis reactions. The synthesis can be a little confusing. So we're going to start with a non-metal oxide plus water. In our non-metal oxide, well, I'll just pick to use P2O3. So suppose you're hit with P2O3 and you're going to combine that with water to make an acid. You know that acids have to have an H in front, and then we write the next elements in order of increasing electronegativity. So it'll be H, then P, then O. We're going to make the assumption that the oxidation state of the P on the left side is the same as the oxidation state of the P on the right side. So we've got to go back and figure out what the charge on the P is over here. So we know that O is -2, and there are 3 of them, which makes -6. So then that has to be +6 to balance it. There are 2 of them, so each one must be +3. So we will assume that that charge stays the same, it's +3, and H is +1. Okay, now let's take a look at our PO polyatomic ions. You know on the periodic table that PO4, at the bottom of our table, it says it's -3. We spoke in class about PO3 also being -3 because these polyatomic ions that change their oxygens by 1 still maintain the same overall charge. What changes is the charge on the P. So we're going to, we know oxygen is -2. We know that this overall thing, I'm going to put parentheses around this to clarify. We do not need the parentheses in the final equation, but I'm going to leave them there just for clarification purposes. All right, so we know that this plus this has to equal -3. Well, 3 plus -2 does not equal -3, does it? It equals +1. So I've got to have a 3 plus something equals -3. All right, I'll take a minute. What is the something? Okay, so X equals -6. Wouldn't 3 plus -6 equal -3? Each oxygen atom is -2. So how many oxygen atoms will I need to make -6? So looks like I'm going to need 3 of them to make the -6 charge. So in this case, the polyatomic ion that we have in the acid is PO3. That would be called phosphorus acid. All right, we still are not quite finished with the formula. We figured out the polyatomic ion, but since that's +1 and the overall is -3 here, you're going to have 3 H's to make it work. So you have to put a 3 down there. All right, so now we have our formulas written correctly. Got to balance. Balancing is easy. So you got 2 P's, you got 1 P, so you put a 2 there. Notice I'm leaving the oxygens till last. Why is that? Because they show up in 2 places. So if they show up in 2 places, it's easier to leave them till the end and try and deal with everything else balancing. So when I put that 2 there, that gave me 6 H's. So I had to put a 3 over here. And when I put the 3 there, that creates 3 oxygens here, plus 3 oxygens there. Makes 6. 2 times 3 makes 6. So we're finished with that one. Okay, for metal oxides and water, let's put a metal oxide here. Suppose it's Fe2O3. Suppose you're hit with that. Plus water, H2O. And that yields a metal hydroxide. So that'd be Fe and OH. Well, we know hydroxide is -1. We know that the iron's either +2 or +3, but we have to look back over here to decide which it is. The reason we know that iron is either +2 or +3 is that we looked at our periodic table and figured that out. Okay, so this is -2, and there are 3 of them. This makes -6, so that's +6. There are 2 atoms, so each one's +3. So that's +3. So if that's 3 and that's 1, put parentheses here, put a 3 outside. Now it's balanced. The charges are balanced. So now we got to deal with the equation, balancing the equation as a whole. Once again, you got oxygen in 2 places. Looks kind of like what we just did, doesn't it? So you're going to end up putting a 2 here to make the ions work, which gives us 6 H's, 2 times 3. So we'd have to put a 3 over here. And when I did that, that made me 3 O's, and 3 O's makes 6. So that works out with our 2 times 3 O's over here. Okay, now non-metal oxide and metal oxide plus salt, if I had to say which one's the hardest, it's probably this one. All right. So, taking a look at nonmetal oxide is, let's make up one. So N2 So N2O, yeah, let's just make a new line here. N2O3, that'd be a nonmetal oxide plus a metal oxide. Let's suppose we have K2O. And makes the salt. All right, now the salt's going to be a metal and a nonmetal combination, so we'd have K and N and O. And you may be wondering why I put them in this order, but you put them in order of increasing electronegativity, like we said up here. All right, so now we know that we're going to assume the charges don't change. So we know K is +1. It's always +1. We know O is -2. We know that the overall NO charge is -1. So we've got to go back and see what the N charge is here. Well, this is -2 times 3 is -6. So it's +6. Divided by 2 is +3. Okay, so 2 times, that's right, +3. Okay, this is 3. So 3 plus X equals -1. So what's X going to be? It's -4. So how many O's does it take to make -4? So you're going to put a 2 down here. All right, and then we put a 2 down here. Okay, so 3 plus -2 times 2. -2 times 2 is -4. So 3 plus -4 equals -1. All right, +1 -1, those charges are already even for the polyatomic ion compared to the K. So now all we have to do is balance the equation. So you got 2 Ks, you got 1 K. Put a 2 right there. That gave you 2 Ns, 2 Ns. 2 times 2 is 4 Os. 2 here, or 3 here, I mean, and 1 there makes 4. So we're good. Okay, individual elements usually combined to form a binary compound. So you'd have Na plus Cl2. Binary compound would be NaCl. So you'd end up with 2C. The charges are okay, +1, -1. So you'd have 2 of these, which makes 2 Nas over here. Put that there. There you go. So that was done. So those are not very hard, the individual element ones. Okay, combustion. Hydrocarbons combined to make carbon dioxide and water. So this also includes hydrocarbon derivatives. So let's just do we'll do a hydrocarbon. So suppose we had propane. Propane's what you use in your gas grills. So C3H8, going to burn it. That's what you do every time you light one of those little gas grills with a propane tank on the bottom. It always makes carbon dioxide and water, always. So you don't have to really think about the formulas, except for maybe if I said propane, you have to figure out how to write that. But carbon dioxide and water is always the same. Oxygen is always the same. Now to balance it, you've got 3 carbons. And once again, I'm leaving the oxygens to last. Okay, and then you've got 3 carbons, and 4 times 2 is 8 H's. Okay, so now I think you're going to find we have a problem. Oh no, we don't. This works out fine. So 3 times 2 is 6, plus 4 makes 10. Over here there's 2, so you put 5 in front, and then you're balanced. And that's all there is to combustion. Now, if you end up with an odd oxygens here, so odd number, you can only have even numbers of oxygens here. So if it's odd over here, then you would need to go back and double this and start again. And that's a little trick for that. All right, so that's the end of that little movie. And that's the end of my examples.